Welcome to Chapter 11 Lesson Review. In this chapter, we are going to review chi-squared tests. The first test we're going to review is the chi-square goodness of fit test. And now a goodness of fit test is used to help determine whether a population has a certain hypothesized distribution expressed as proportions of individuals in the population falling into various outcome categories. And there are two types of goodness of fit tests. Your first one being equal proportions. This is where all the proportions are expected to be the same. Your second goodness of fit test will be fixed or given proportions. And this is where your proportions are expected to follow given values. And for a goodness of fit test, you want to know how to write your hypothesis. And you want to sort of kind of follow this outline. So your null hypothesis being the stated distribution of the categorical variables given to you in the problem in the population of interest is correct. And for your alternate hypothesis, you want to state that the stated distribution in the population of interest is not correct. So you want to kind of follow that outline and have your wording correct for your hypothesis. And secondly, you want to know how to calculate your chi-square statistic. So this is the formula for your statistic. It's easier to put it in your calculator because that way it'll spit it back out for you. But it is still good to know just in case a multiple choice problem asks you to plug in a number and find the observed value or to find the expected value. That way you can plug and chug, get a number out, and then it's easier to do it that way. But it's just good to know. But also, like I said, you can put it in your calculator. It'll find it out for you. Also, you need to know how to find the expected counts. And the expected counts for the equal proportions goodness of fit test are all the same. They are found by dividing the total of the counts by the number of outcome categories. And then the expected counts for the given proportions goodness of fit test are not all the same. They are found by multiplying the total of the counts by each given percentage. You also need to know how to check your conditions for a goodness of fit test. Your first condition being random. In the problem, they'll most likely state that they obtained a random sample. And also, if it's for an experiment, they'll say that the treatments were handed out randomly. So in the problem, they'll most likely state the word random, which is what you're looking for. Your second condition would be independent. This is when you check your 10% condition. Here you do 10 times your sample size would be less than or equal to your total population. Your third condition would be your large counts, and this is when you need to check to see if your expected counts are at least 5. Now, if all these conditions are met, you're able to go ahead and go forth with your goodness of fit test. You also need to be able to calculate your degrees of freedom. And for a goodness of fit test, your degrees of freedom is equal to n minus 1, and this is where n is equal to the number of outcome categories. Now we'll do an example, and here we want to test to see if the number of moose in each habitat is proportional to the total acreage. And so we'll go through our state plan, do, conclude. So first we'll do state, and here this is when we'll say we want to perform a goodness of fit test, where HO is the number of moose is proportional to the amount of acreage in the 4 habitats, versus HA, which will state the number of moose is not proportional to the amount of acreage in the 4 habitats. In this part, you also want to state that your alpha level is 0.05. Since it didn't say it in the problem, we'll just assume that our alpha level is 0.05. Next will be plan. Here we need to say that if the conditions are met, we will use technology to perform the test. We'll perform a chi-square goodness of fit test. And for this problem, they stated that the conditions have been met, so we don't really have to worry about going through the conditions. But it is good to still know the conditions just in case they didn't state that. But for this one, we'll go ahead and progress with the test since it already said that the conditions have already been met. So next would be do. We'll have to state the conditions have been met, and then we will label our inputs from the calculator. So we will go to stat, we'll go to test, and then we will go to option D. Here you will insert or edit your list 1 to have your observed counts. You'll also have your expected counts in list 2, And then once you have calculated your degrees of freedom, you'll do calculate. And then you will also want to record your results. So your chi-square statistic will be 43.6739. And if you notice, your p-value is so small that for your conclude, all you have to say is our p-value is smaller than our alpha level 0.05, which means that we will reject our null hypothesis. We have convincing evidence that the number of moose is not proportional to the amount of acreage in each habitat. All right, and then secondly, your other chi-square tests, you are testing for homogeneity and independence. A good thing to know for these tests is how to read and how to create a two-way table. And this is when there are two categorical variables, and this is when data can be arranged in a row and column format, and this is called a two-way table. And for homogeneity, it is about the distribution of a single categorical data among several populations or treatments. And then independence is about the association of two categorical variables in a single population. And for these tests, your hypothesis is about the same. You just really want to focus on your wording. So one way that you could put it is for your null, you can say there's no association between the variables. And then HA would be there is an association. And then also you can say for independence, your null hypothesis would be the categorical variables are independent. There is no association. And then for your alternate hypothesis, you'll say the variables are not independent and that there is an association. You don't want to say that they're dependent. You just want to say that there is an association. And for checking conditions and calculating your test statistic is both the same as if you were performing a goodness of fit test. So you can refer back to the other slides if you need to know the conditions or how to calculate the test statistic, but that's the formula for it just in case. And then the expected counts is a little bit different. For an association test, the expected counts can be found with this formula. It's pretty easy. Expected counts is equal to your row totals and then your column totals divided by your table total. All right, and then calculating your degrees of freedom is also different from a goodness of fit test. For this one, you'll do your rows minus 1, your columns minus 1, and then you will multiply those two numbers together. So it's pretty easy. Just have to see it in a problem. So for this example, we are given 300 first graders, 100 being boys and 200 being girls, and we are given 3 different television shows. And then they put this in a two-way table, and we want to see if the boys' preferences is different from the girls' preferences. And they gave us the alpha level for this one, which is the usual 0.05, and then we'll perform the test the same way as a goodness of fit test. And so first, we'll do our state. We will say we want to perform a test where HO, there is no difference in the preference between boys and girls, or we can say that they're equal to each other, versus HA, that there is a difference between boys and girls preferences in the shows at alpha level 0.05. Next, we'll want to do the plan. If conditions are met, we will use technology to perform a test. So first one being random, they selected a random group of boys and girls. It states that in the problem. Next, it'll be independent. This is when we do 10 times our sample size, which was 300, is less than or equal to the total children that watch the programs. I'm sure it's more than 3,000 kids that watch those different TV shows. Thirdly, we'll do our large counts, and all of our numbers are greater than 5. Third, we'll do our do. Conditions have been met. Before you perform your test, you want to make sure that you enter your data into a matrix. The way you do that is you will do second matrix, and then you'll go down to edit. You'll edit matrix A, and then you do your columns by rows. You'll enter the data, and then After you finish that, you do stat, test, and then you will go down to option C. Here you will make your observed matrix A, expected matrix B. It'll calculate your expected values for you after you're on your test. So then you want to just continue down to calculate. And then it'll spit back out your chi-square statistic and your p-value. Again, notice how your p-value is so small and that it also gave you your degrees of freedom. And you want to make sure that you record all your results down in your paper. Also, when you're taking a test, you want to make sure that you are recorded exactly what the calculator gives you. So now that you have noticed that your p-value is so small, once again, you will state that our p-value is smaller than our alpha level 0.05. Then we will reject HO. We have convincing evidence that there is a difference in preference for the shows among girls and boys. So that's pretty much all the review that we'll have for chapter 11. There are more practice problems or more examples that you can review in your textbook. Here's a couple of page numbers that you can do. Some of them are a little shorter than others. Most of them will have you check the conditions. Other will have you perform the whole test. It's good to review all of them just in case. It's very helpful. I hope this review was helpful, and I hope you have a great rest of the school year. Thank you, and good luck.